Okay, question 11 is a nice 9 marker, so it is the big question of the paper. Now it's a real life differentiation problem, which is pretty cool. Questions like this shows the power of calculus in real life, which I always think is pretty cool. So, Recti makes open-topped cylindrical planters from thin sheets of galvanized steel. She bends a rectangle of steel to make an open cylinder. She then welds the joint together. She then welds this cylinder to the circumference of a circular base. So we got our diagram here. The joint is that vertical line going up the length or height of the cylinder. We need the total capacity of the cylinder to be 8,000 centimeters cubed. Welding is time consuming, so Recti wants the total length of weld to be a minimum. Our job is to find the values of the radius and the height such that the total length is a minimum. Fully justify your answers, giving them to suitable degrees of accuracy. Okay, so big question. Let's work out what we know. So we know that we want the volume of the cylinder to be 8,000 centimeters cubed. Now the volume of the cylinder is going to be just like any other cylinder, the area of the base times the height. So pi r squared h. Now we also know that we want that to equal 8,000. Okay, now what we can also work out is the total length of weld in terms of R and H. So I'm going to call this L. Now the total length of weld is 1 lot of the circumference of the base, so that's pi times diameter, or 2 pi r. Add the height of the cylinder, because that's the length of the joint. So it's 2 pi r add h. Now it's this that we want to minimize. Okay, so how are we going to do that? Well, remember that we can use differentiation to find minimums and maximums. The problem that we have here at the moment is that the length is in terms of the radius and the height of the cylinder. What we need is an expression for the total length in terms of either just the radius or just the height. So this is where our volume equation comes in handy. So we know pi r squared h is equal to 8,000. So using this we can get an equation either for h in terms of r or r in terms of h. So I'm going to work out what h is in terms of r. If we worked out what r was in terms of h, we're going to get square roots, and that's going to be scary so let's not do that. So, h is 8,000 divided by pi r squared. So, let's rewrite our expression for the total length. So the length is 2 pi r add h. So add 8,000 times pi r squared. Now I'm going to write this as 8,000 over pi times r to the minus 2. So, at this point, we now have an expression for the total length of the world in terms of just one variable. So, what we can do now is, first of all, differentiate this to work out the value of r. That would give us a stationary point. So, dl by dr is going to be 2 pi. Now, the power of minus 2 comes down and multiplies the 8,000 over pi. So we're going to get minus 16,000 over pi, and that's going to be r to the minus 3. So, we want, for a minimum, we want dy by dx to equal 0. So we should probably say that. So, for a minimum, dy by dx, or well, dl by dr is equal to 0. So, I'm going to clear this up and continue. Okay, so from here then, we are setting 2 pi minus 16,000 over pi r cubed, r to the minus 3 means 1 over r cubed, equal to 0. Now, if we multiply through by r cubed, in fact, let's multiply through by pi r cubed, then we're going to get 2 pi squared r cubed minus 16,000 is equal to 0. 2 pi squared r cubed is equal to 16,000 r cubed is equal to 16,000 divided by 2 pi squared, so 8,000 divided by pi squared, so r is equal to the cube root of 8,000 over pi squared, which is, if we go to 2 decimal places, that's going to give us 9.32 centimetres. So that's our value for R. Now, from that, what we can also do is work out the value of H. So remember that we knew pi R squared H was equal to 8,000. So H is 8,000 over pi R squared, which is 8,000 over pi times 9.32 squared. Now that is going to give us 29.32 centimetres. So we've got these values of R and H. What we don't necessarily know though at this point is that this gives us a minimum. So what we need to do now is check that this is indeed a minimum. So if R equals 9.32 gives a minimum, and then the second derivative, d squared L by dr squared, will equal, no it won't, we want a minimum, so the second derivative would have to be greater than 0 when R is 9.32. So we now need to find our second derivative. Okay, so dl by dr was 2 pi minus 16,000 over pi times R to the minus 3. So our second derivative is going to be, well, 2 pi is just going to differentiate to 0. Now our power of minus 3 comes down and multiplies the minus 16,000. So we get positive 48,000 over pi. Now it would be times R to the minus 4, or stick the R to the 4 on the bottom. Now we can see that is positive. So when R is positive, d squared L over dr squared is positive. So R equals 9.32 and H equals 29.32 gives us a minimum length of, well,